Today we'll be deriving the power, product, and quotient rule using logarithmic differentiation. My name is Quotient, and let's get started. For the power rule, in Leibniz's notation, it can be seen as the derivative with respect to x of x to the n. And we're trying to figure out what that should equal to. We're trying to evaluate the derivative with respect to x of x to the n. So let's do this step by step. So the first step here is setting y equal to x to the n. Okay, so y equals to x to the n. And one thing I'm going to define off the bat is, of course, if y equals to x to the n, then dy by dx equals to dx of x to the n. We will be using the same type of format for all of our rules here. So once we do that, we're going to take the natural log of both sides. So natural log of y equals to the natural log of x to the n. Our third step is to simplify the right side here using properties of logarithms by bringing this n, let me use a different color here, by bringing this n down. Okay, so then we'll get ln of y equals to n ln of x. The fourth step is taking the derivative with respect to x on both sides. Now, the reason why we can do this is because the derivative is an operation. Just like taking the natural log of both sides, we can take the derivative with respect to x of both sides. Now, one thing I'm going to do here, I'm going to skip a step here. Since n is a constant, we just defined, or I told you off the bat, right? If we're taking the derivative with respect to x of x to the n, n will be a constant. That's a precondition. That I'm just going to factor out the constant and then do the derivative with respect to x of ln x, because the result will be exactly the same. So then the fifth step is we'll get 1 over y dy by dx equals to n times 1 over x, because the derivative with respect to x of ln x is 1 over x. Okay, so then the sixth step, I'm just going to multiply both sides by y. So I'm going to do 1 over y dy by dx. I'm going to multiply both sides by y. N times 1 over x times y. So then our seventh step here, and of course these y's will cancel. Our seventh step is dy by dx equals to, of course, n times 1 over x times y. So now we're going to do the substitution here. So the eighth step, just substitute y in for x to the n, right? This will be x to the n. Let me erase that. Exponent x to the n. This will be x to the n. So this will be then ddx of x to the n equals to n times 1 over x times x to the n. And now, I'm just going to, right here, the ninth step is just using our properties of exponents. So I'm going to actually make it a 10th step here, because I want to rewrite it as n times x to the n over x to better sort of understand this. So we have the same base here of x. Let me use a highlighter here. We have the same base of x, and this is x to the first. This is x to the first, so we can do the subtraction, right, using properties of exponents. So then therefore the derivative with respect to x of x to the n is n x to the n minus 1. So this is the proof of the power rule using logarithmic differentiation. Let's move on to the next the next rule here, which is the product rule. So again, we're going to stick to the same format here, but we're trying to find the derivative with respect to x. Instead of u and v, which is commonly used, I'm just going to do f of x, g of x. Okay, so we're trying to figure out what this is. So our first step here is, of course, set y equal to f of x, g of x. And of course, if y equals to f of x, g of x, then dy by dx has to equal to the derivative with respect to x, d dx, of f of x, g of x. So the second step here is to take the natural log of both sides. So natural log of f of x, g of x. And the third step is to use our properties of logarithms, right? Because we know that again, it's going to be the right side for all of these. So the right side here, this will split into, try to erase that. This will split into the natural log of f of x plus the natural log of g of x, because if there's multiplication in the argument here, then we can do the addition. So we'll get the natural log of y equals to the natural log of f of x plus the natural log of g of x. So now we're going to take the derivative with respect to x on both sides. Now, since these are individual terms, I am just going to rewrite it as the derivative with respect to x of ln of f of x plus the derivative with respect to x of ln of g of x. Okay, and now our fifth step here, we're just going to evaluate the derivative on each side. So this will again be 1 over y dy by dx. Now on the right side, I'm just going to switch it over to Lagrange's notation instead of Leibniz's notation, just because it's easier to read. So I'm just going to write this as 1 over f of x, and then using our chain rule, derivative of the inside, which is f of x. I should put another parentheses here. This should be times f prime of x, or d dx of f of x, or df of x by dx. And then here, this will just be 1 over g of x times g prime of x. Okay, so now we're just going to multiply both sides by y. Okay, and these guys will cancel. So our sixth step here is going to just be dy by dx equals to 1 over f of x times f prime of x plus 1 over g of x times g prime of x times y. And now what we're going to do is just substitute everything in terms of f of x d dx of, or we're going to substitute y for f of x g of x. So here we'll get, for the seventh step, is d dx of f of x g of x, which is what we're trying to find, equals to then 1 over f of x times f prime of x plus 1 over g of x times g prime of x times f of x g of x. Alright, so now we're just going to use our distributive property here for our eighth step. So our eighth step here is we'll get the derivative with respect to x. I hope I do not run out of space here, so I do apologize. It's looking a little cluttered right now. So derivative with respect to x of f of x g of x equals to then 1 over f of x times f prime of x times f of x g of x plus 1 over g of x times g prime of x times f of x g of x. Okay, so let's focus here on this term first. Let me use a highlighter here. So for this term right here, what can we simplify? So we can cancel out the f of x here. So then we'll get f prime of x, g of x, and then for this term here, I know it's a little messy, sorry about that, we can cancel out the g of x. The g of x. So now, I'm pretty sure, therefore, d dx of f of x, g of x, equals to f prime of x, g of x, plus g prime of x, f of x. So that's our proof of the product rule. For the quotient rule, it's also going to be very similar. So are all these. It's just really logarithmic differentiation. Using our properties of logarithms, knowing the derivative of the natural log of x, the chain rule, that's really the gist of it. So let's move on to the next, or the final one here, which is the quotient rule. So this is known as the derivative with respect to x. We usually use u over v, but I'm going to also just use f of x and g of x this time as f of x over g of x. So we're trying to figure out this. So our first step here is set y equal to f of x over g of x, and if this is true, then dy by dx has to equal to d dx of f of x over g of x. So now for the second step, just take the natural log of both sides. So natural log of y equals to the natural log of f of x over g of x. And again, focusing on the right side here, knowing our properties of logarithms, we can just do the subtraction, which will then be the natural log of f of x, and instead of plus this time, we do minus the natural log of g of x, because we're in the argument, there's division. So then our third step is the natural log of y equals to the natural log of f of x minus the natural log of g of x. Okay, and then the fourth step is we take the derivative with respect to x of both sides, d dx of ln of y equals to, again, two separate terms, so I'm just going to take the derivative with respect to x of each term, ln of f of x minus d dx of ln of g of x. Okay, and now, fifth step here. This will be 1 over y, dy by dx. And then for the right side, I'm again just going to use Lagrange's notation. So this will then be 1 over f of x times f prime of x minus 1 over g of x times g prime of x. Okay, and now we're just going to multiply both sides by y. Okay, great. So now, 6, this will be dy by dx equals to then 1 over f of x times f prime of x minus 1 over g of x times g prime of x, just going to write here, times y. So then for a seventh step here, we're just going to substitute y in for f of x over g of x. So then this will be d dx of f of x over g of x equals to 1, or I'm just going to write 1 over f of x times f prime of x minus 1 over g of x times g prime of x times f of x over g of x. And again, we're just going to use our distributive property. So we'll get d dx of f of x over g of x This will then equal to 1 over f of x times f prime of x times f of x over g of x minus 1 over g of x times g prime of x times f of x over g of x. Look, I didn't run out of space here. So now we're going to just try to see if we can do any canceling out here. So let's look at this term first. Alright, so with this term, I see that we can cancel out an f of x. Oops. We can cancel out an f of x. And then with this term, we can't cancel out anything. So what I'm going to do is just rewrite this 9. Okay, maybe I will run out of space. Dx of f of x over g of x equals to f prime of x over g of x minus g prime of x f of x over g of x squared. So now once we are here, we want to get a common denominator. So in order to get a common denominator here, we're going to multiply this term here, the numerator and denominator, by g of x. So then we can get that common denominator of g of x squared. So then our 10th step, which is of course our, I'm just going to, we can just say that therefore the ddx of f of x over g of x equals to g of x times f prime of x minus f of x times g prime of x, oh god, almost ran out of space, over g of x squared. So that is it, guys. That is the proof, not like a formal proof, but like a way of just deriving all of these rules of differentiation using logarithmic differentiation. So hopefully this gives you a better way of like understanding, you know, that these rules are just not like made up. They all can be easily understood. Of course, there are other ways to prove all of these rules. Log differentiation is not the only way. It's, I would say, the easiest way for students to really understand it. Understand these, like where for example, the g of x times f prime of x minus f of x times g prime of x over g of x squared. Like, how is that possible? How does that give us the derivative of, you know, f of x over g of x? Just understanding that it all is possible to think about. So yeah, this really is something I wanted to go over because I'm going to try to not make this video too long. It's also just, it makes you not want to have to memorize this, because if you're really in that scenario where you forgot the rule, you can just use log differentiation to get it. All right, so I'll see you in the next video.